Hi everyone. So today's lesson is on absolute value and why does it even matter and what is it? So in Algebra 1, you should have learned about, and pre-algebra, learned about absolute value. And this right here, these bars right here, this is actually pronounced the absolute value of x. Those two little bars are important. They are not the same thing as parentheses, but they do act like parentheses when using order of operations, okay? So, but what is actually the meaning of absolute value? Well, the meaning of absolute value is the distance x is from 0 on a number line. And since we're talking about distance, we can't go a negative distance. So when we take the absolute value of something, the result of it always has to be positive, okay? It has to have a positive result. If it doesn't, well, then it shouldn't make sense. All right, so does this expression or equation make sense? The absolute value of -2 equals -2. Well, if I take the absolute value of -2, I'm taking its distance, so its result should be positive, and it is not. So no, it doesn't make sense. There's really no solution to this. All right, now instead of putting a number in, I'm going to put x in. If I take the absolute value of x, its result has to be positive. Is it positive? No, so this doesn't make sense. It's no solution. And let's go back to the definition. This is actually saying the distance from x to 0 is the distance from x to 0. Well, if I go any distance, it has to be positive. Okay, how do we solve an absolute value equation? We've done a few, okay? So let's look at some. So I gave you 2 times the absolute value of x minus 3 equals 5. You solve an absolute value equation just like you solve an equation, except remember I said that these bars are really tough and strong. You can't distribute into absolute value, so never do that. But you want to isolate the absolute value bars. So the first thing we would do would be we would add 3. And we will get 2 times the absolute value of x. 2 is being multiplied to it, equals 8. Then we divide by 2. So we get the absolute value of x is equal to 4. All right, so now we're going to look at that definition. So what that's saying is that the distance x is from 0 is 4 units. So could x be here at 4, the number 4? Yes, it could. But it also could go 4 in the opposite direction, which would mean it's at -4. So when we're looking for solutions to absolute value equations, there could be a situation where there's 2 answers. Most of the time there will be. So x in this situation could be 4 or -4, or 4 and -4. Actually, it is and. Okay, remember that absolute value involves distance. That's the most important thing for us to remember. All right, and we're going to be talking more about what absolute value is in real terms in word problems, but let's look at solving more complicated absolute value equations. There's a process we do have to go through. The first thing that you want to do is you want to isolate the absolute value bars, okay, if necessary. In this case, I have the absolute value of 2x plus 5 equals 13. I don't have to isolate the bars because they're already isolated. There's nothing around it. Then, to solve it, you write 2 equations. You take it out of the absolute value bars and do 2x plus 5 equals 13, just like the equation's written. Then, you write another equation, 2x plus 5, never changing what's inside the bars, never. But you have to set it equal to the negative value because it could have gone in that negative direction. This is how we solve them. All right, so we solve them like equations. We subtract 5 on both sides. So we're going to get 2x equals 8. And then we divide by 2. And so I know that x equals 4. So that is one of the solutions to this equation. Then I subtract 5 on this equation, and I get 2x equals -18. and then I divide by 2, and so I get x equals negative 9. All right, so that's telling me that both 4 and negative 9 are solutions. To graph that, it's just those numbers. Oops, let me use red. And so we plot them directly on that equation. So let's think about that. 2 times 4 plus 5, and then I take its absolute value. So 8 plus 5, does that give me 13? Yes, it does. So it's a true statement. Let's look at negative 9. 2 times negative 9 plus 5. Well, that's negative 18 plus 5, which is negative 13, but it's in absolute value bars. So when I take an absolute value, I have to make whatever's inside positive. So my result would be positive. So that's how I have 2 solutions. All right, there's 2 additional examples. We're going to be reviewing those in class to make sure everybody understands. Now let's move on to inequalities. All right, so yesterday we talked about compound inequalities. And compound inequalities is how we solve absolute value inequalities. They help us solve them. All right, so let's look at model number 1. This is red. The absolute value of 4x plus 1 is less than 5. We read it based on the absolute value. So it's a less than. All right, so first we have to isolate the bars. In our model, the bars are isolated. So then I write one compound and inequality. And you may remember with and inequalities, we sandwich the x value in between 2 values. So how do we sandwich the x value or the absolute value in between 2 values? Well, remember, we could go in the positive direction or the negative direction. So I take my absolute value equation out of the bars and I write it just like that. Now, I put a negative 5 on the other side. I've made an absolute value and inequality to solve it. Now notice that the inequality symbols are always pointing the same direction and they're always pointing to the left. All right, now when we solve this, we have to solve it simultaneously like we did compound inequalities. So we add 1, we add 1, we add 1. And we get negative 4. We subtract 1. I wrote it wrong right here. Let me erase. I made a mistake. I just rewrote it wrong. So it should be 1 plus 1. Okay, so we subtract 1 to everything, and we get negative 6 is less than 4x is less than 4. Then we divide everything by 4, and I'm going to have to come down here a little bit. So I get negative 3 over 2, I simplified 6 over 4, is less than x is less than 1. So the graph of that is going to be negative 3 halves and 1 and everything in between it, and I have those open circles because it's just less than and not less than or equal to. So less than absolute value inequalities have and compound inequalities as their solution. Because look, this is an and compound inequality. I say less than, it's an and inequality, which means that we sandwich it in between 2 values. All right, so we're going to do model number 2 in class, just to be as a concept check. Now let's look at greater than, okay? Absolute value greater than, we solve them like our or compound inequalities. So first, again, we isolate the bars. 4x plus 1 is greater than 5. So we are going to write 2 inequalities, 2 compound inequalities using the word or. So first, we write our first inequality exactly as it's written, never changing what's in the bars. Then we write the word or. All right, now this is the tricky part. We take exactly what's in the bars, we never change that, but then we change the direction of the inequality symbol and we change the sign of the number. So we keep, we change, and we change. We keep, change, change. All right, and then we solve them. So we subtract 1 on both sides. So we get 4x is greater than 4, and then we divide by 4, and we get x is greater than 1, or. The or comes with me. It is part of my solution. I subtract 1 in the other inequality. I get 4x is greater than or equal to negative 6. I'm sorry, it's less than or equal to negative 6. We divide by 4, and we get x is less than or equal to negative 3/2. So let's look at that. Now, if I graph that, I've got 1 here, and I want x is greater than it, so it's bigger, so it's going to the right, whereas x is less than negative 3/2 is everything to the left. And remember I said that for the most part, OR graphs are going to point out unless there's overlap, okay? Okay, so those are the 3 types of absolute value equations and inequalities we're going to be talking about. Equations, less than absolute value inequalities, and greater than absolute value inequalities. So to review and recap, to solve an absolute value less than inequality, you must make an and absolute value inequality to solve. I'm sorry, an and compound inequality to solve. To solve a greater than inequality, you make a gap with the word or. So you write 2 compound inequalities using the word or. Okay, thanks for listening today, guys. We will be practicing this tomorrow in class. Bye-bye.